let me have one or two examples, those based on a sort of word problem. A person places $20,000 in a saving account. Which pays 5% interest per annum compounded continuously. Find number A, the amount after 3 years. After 3 years, and B part, the time required to double the amount. To double the amount. So you can have this. So a person places $20,000 in a saving account which pays per 5% interest per annum compounded continuously, and it means 20,000 he has, for the first year he has 5% interest, and that amount is accumulated in the principal value is pay, and then what is the, for the next year, what is the amount he has going to have 5% on that, and then on that, and then on that. But here one condition is, if you have placed your money in a saving account, you are not going to draw anything and no more deposit. So that is the criteria for it. It means it doesn't make any, you are going to have $5,000 taken out then put in. No. Once you have put, you have to keep it. No withdrawal or no more deposit. So this equation A is using solution. Using equation A, and T is equal to CEKT, where NT is the amount of the substance, right? So at T equal to 0, NT, I mean N0, what is that? Which is $20,000 initially. So put in one equation number A, $20,000 is equal to CEK0, and T is the amount of the substance, but initially at T equal to 0 it is $20,000. So putting T equal to 0 and T is 20,000 is equal to this. This implies C is equal to 20,000. If C is 20,000, put in A. Put in A. So this is NT is equal to 20,000 EKT. Now what is K? K is constant of proportionality. In this case it is 5%. K is 5%. K is equal to 5% mean 5 by 100. 5 by 100 mean 0.05. So putting in the equation. So you are left with NT is equal to 20,000 E 0.05 T. That's all. So in each questions, whether the problem is growing up or whether a substance is growing up or decaying down, you are using this equation, and eventually by looking at the word problems, find a function which is time dependent. It means you have to find C and K. If you find C and K, then this NT is time dependent function. I mean your job is finished. Now I am coming off. What is the amount after 3 years? What will you do? T is 3. Solving this. Now, when t is equal to 3 years, so nt will be 20,000, 1, 2, 3, e 0.05 times 3. Solving this and getting the answer. So you have using calculator or something. So the time required to double the amount, same. Look at this. The time, you have to find time to double the amount. It means amount will be 40,000. 40,000 is equal to 20,000 e 0.05 t. Look at that. Solving by taking natural log or something like that, you are getting the time when the amount of the person will be double when a constant interest rate of 0.5% is going to be there. Look at that. So you can solve for the t. It means this 40 cancelled, 4 by 2. This implies e 0.05 t is equal to 4 by 2 is 2. 4 by 2 is 2. To taking natural log 0.05 t, ln e is equal to ln 2. Ln e is 1. So dividing by point something. So you can have ln 2 and divided by minus 0.05. So you are getting t. So this is something amount after a double amount. You are looking for the time for double the amount, 40,000. Let me have another example. The next is the second example is related to the first example. What constant rate is required for the initial amount to double in 6 years time. 6 years. Now this is related to that. Time is given, but initial amount is n0. It could be double. So what time is there so that initial amount will be double? I mean, if you are solving this question, you will see after for double the amount, what will be time? So you can find time. But here 6 year time is given to double the amount. So what constant interest rate must be given by the bank? Solution. Using equation A, which is nt is equal to CEKT. At t equal to 0, n0 is n0. Let me have, this is the initial amount. Right? At t is equal to 0, initial amount is this. So that become n0 is equal to CEK0. This implies C is equal to n0. This is the initial amount n0. So equation 1 becomes, nt is n0 EKT. This is going to be. Now this initial amount will be double and in 6 year time. It means t is equal to 6 and t is 2 and naught. Right? So when t is equal to 6 years and naught is equal to 2 and naught, double. So this equation, the last equation becomes nt. Initial amount t, right, that's its n naught is that. This is 2 n naught is equal to n naught e 6k. Look at that. When the initial amount is n naught will be 2 n naught. So how much interest rate will be given by the bank? in order to 6 year time. So that double the amount. 6 year and naught is 2 and naught. This and naught cancel. 6k ln E is ln 2. This implies k is equal to 1 over 6 ln 2. Solving this. So you can have. There is no minus. This is plus because this is plus there. This is plus. So something. ln 2. Finding the value of ln 2 divided by 2, 6, and you are getting some constant of proportionality, which is the interest rate given by the bank in order to double the amount in 6 year time. Let me have one more example related to the decay problem. I will have. Let me have one more so that a bacteria culture is known to grow. A bacteria culture is known to grow at a rate proportional to the amount present. At a rate proportional to the amount present. If after 1 hour 1000 strands of bacteria are observed, and after 4 hours 3000. After 4 hours 3000 strands of bacteria. Find number A, an expression. Find an expression for the approximate number of bacteria. For the approximate number of bacteria in the culture or B, originally in the culture. Number of bacteria originally in the culture. Originally it was how many bacteria originally in the culture? Right. So you are given, you do not have an original amount. What is given? After 1 hour it is observed there are 1000 strands, and after 4 hours there are 3000 strands. It means the problem is the bacteria are growing. So what was number of what is the number of the bacteria originally? They were 500, they were 600, they were 700. What is? So you have to find that, an expression. Solution using the same equation, which is NT is equal to CEKT. Right. So after 1 hour 1000 strand, 1000 CEK, T is 1, and after 4 hour 3000 strand, CE 4K. So two equation, two unknown, solving for C and K. If you are solving, you can find C, you can find K by using calculator. You are solving those, putting the value of C and K there. Putting the value of C and K in equation A. So that is the required expression you are looking for. Look, an expression for the approximate number of bacteria. If you have find C, you have find K, this expression is time dependent. So as the time moving, it is going to be increasing, so number of bacteria will increase in the culture. And this is the two equation, two unknowns, solving them simultaneously. If you are putting C and K, but how you will find originally how many bacteria are there? It means when T equal to 0. When T equal to 0 and 0 is C. So it means C is the amount which was originally in the culture before you have started the time, after 1 hour and after this. So this you can do it. So let us solve one more example for related to the decaying of a radioactive substance. Because 3 example, 2 for growth, 2 for the saving account, the amount of money in the saving account, 1 is the bacteria culture. Let me have one which is the radioactive substance, decay of radioactive substance. It means whether the process is growing up or decaying down, one equation is all. You are using only one equation. Let me have a word problem which is a little bit lengthier. A certain radioactive substance is known to decay. A certain radioactive substance is known to decay at a rate proportional to the amount present. Amount present. If initially 50 milligram of the substance present, and after 2 hours it is observed that the material has lost 10%, and after 2 hours it is observed that material has lost 10% of its original mass. Find number A, an expression for the mass of material at any time. It means the first which I have asked, find the expression. It means the function the expression is only time dependent. You find C, you find K, and that is the expression which is time dependent. You have to find number B, that time mass of the material after 4 hours. After 4 hours. After 4 hours, what will be the mass remaining? Initially, it is the mass. So after 4 hours, it is decaying. So C, time at which the material is 1/2 of its initial mass. Time for half-life. Time required when the material has decayed 1/2 of its initial mass. The time required for half of its initial mass. If lost, what will be the time? So, solution using equation A, which is this, NT is equal to CEKT. So at t equal to 0, initially this. At t equal to 0 and 0 is equal to 50 milligram. Putting in there. So 50 is equal to CE K 0. This implies C is equal to 50. C is equal to 50, putting in A 1. Put in 1. Equation 1. So this is NT is equal to 50 EKT. This is going to be one thing you have found, which is C. When T is equal to 0, initial mass of the material is 50 gram. So after 2 hours, now after 2 hours, the material has decayed 10% of its original mass. 10% of original mean 10% of 50. It means 10 by 100 of 50. So this goes, which is 5. So after 2 hours, the material decayed 5 milligram. I mean, it means the 45 is remaining. 10% it lost. So it means 10% of 50 is 5 milligram is lost. So at t equal to 2 hours, we have 45 remaining. 50 E2K. This is going to be 10% lost. The remaining is 45. 10% of 50 is 50. So you are solving this. This implies E2K is equal to 45 by 50. So taking natural log, 2K ln E is equal to natural log 45 by 50. So you can use this or something. It means K is equal to 1/2 natural log 45 by 50. This is whatever it is, using calculator and finding the value of K. So your K is there, your 50 is there, putting here. Let me call it 2. Putting the value of K in equation 2. So it becomes N of T is equal to 50E. And I hope so, since the process is decaying, there must be a negative exponential. Negative exponential reflects that it is, K will be minus 0.053. This is minus 0.053. Let me have minus 0.053 T. This is going to be K, because if you calculate, you are going to have this. So this is the required expression, which is part A, an expression for the mass of the material at any time. Once you are putting time, you are getting the required material. The mass of the material after 4 hours. After 4 hours, this is A part this and B part, and T is equal to 50 E minus 0.053 into 4. Simplifying and getting the answer. So mass of the material remaining after 4 hours and the half-life time. So the time required for initial amount to half. It means here you are putting C part 25 is equal to 50, because 25 is the half material, half-life, and A minus 0.053 T. Solving for T. So if you are solving for T, that is the time required for the initial amount to half, which is half lifetime of radioactive substance.